Now we're going to talk about complex numbers. So there is such thing as complex numbers that are kind of different than real numbers. And now the simplest definition of an imaginary number, all right, that imaginary number is always going to happen when you try to take the square root of a negative number. In this case, by definition, I, or the imaginary number, is defined as the square root of -1, okay? And I squared is -1. Now, if that doesn't make sense, you really just have to remember this one. Right now, I squared, think about it. I'm just going to write it up here. You don't have to necessarily write it down. I just need you to remember. I squared is the same thing as I times I, right? Which would be the same thing, according to this, as the square root of -1 times the square root of -1. Well, if you multiply a square root of one number times the square root of the same number, that basically gets rid of the square root, and you end up with just the inside, which in this case is -1, okay? Now in general, for example, just like any other number, I to the 0 power is 1, I to the first power is square I, or square root of 1, I square is -1, just like we talked about, I to the third. And remember, you can just think of this. I to the third is basically this times this, okay? But the pattern repeats, okay? Notice that you have I, -1, I, 1, I, -1, so it just kind of keeps repeating, okay? So let's go over some of the examples. Now, first, we're going to try to simplify. Now, to simplify, we're actually going to do the factoring tree, and I hope you remember this. On the factoring tree, you're basically trying to, don't worry about the negative for now, just 72. You're going to break that down into factors if you can. So for example, 72, the first one I can think of would be like 2 and 36. Okay? And then now, 36 is like 2 and 18, and then 18 is, 2 and 9, and then 9 is 3 and 3. I don't know if you remember that or not. And so basically what you do is you're looking for pairs. Okay, so you're looking for pairs. So we have this one and this one, right? And if you have those two, what that means is that you would pull that out and you would write this as 2 times 3 square root of, in this case, that would be a -2, all right? So again, it might be kind of hard to see, but this negative, remember this 2 came from that 2, and that negative is just that negative. Now, we're not quite done yet. What we do after that, well, we're going to multiply that. And -2 is the same thing as -1 times 2, okay? And with square roots, it turns out that I can actually split the square roots into 2 different square roots. And by definition, this right here, the square root of -1 is I. So this is 6I square root of 2. Okay. So let me kind of simplify this further, right? Now I show you the reason. Now the way to do it faster, all you do is you're actually going to find a factor. So if this is the square root of a negative, I know my answer is going to have an I in it. It just has to. All right, so if I break this down, I get 2 and 12, 4 and 3, I'm going to write this as 3 and 4. And then 4 is 2 and 2. Okay? I have a pair here. So my answer is going to be 2. Now because this is negative, I'm going to write an I. And on the inside, I'm left with 2 times 3. So this is 2I square root of 6. Okay, so that's the answer for that. All right. Now, there's an example of this right now, but we're going to cover more examples, so if you don't get it, this next example, you're fine. We're going to talk about it more in the back. All right, when you're adding what's called a complex number, and a complex number is actually a real number added with an imaginary number, so what you do is you add just the real numbers, which is 2 and 2, which is 4, and then you're going to add I minus I, which in this case is 0, so this is the answer for that. All right, so and again, we're going to talk about it in more detail here on the back in just a second. Okay, so now to solve each equation, all right, to solve each equation, all you have to do in this case, instead of factoring, which you could do, instead of factoring, we're actually going to subtract. Now notice the difference. On this one, only have two terms. So if you have two terms, then you can actually do this. All right. You're going to subtract the 45 from each side. So you have 5x squared is equal to negative 45. And then you're going to divide by 5. So you have x squared is equal to negative 9. Okay? And then now, to get rid of the square, you're going to take the square root. Okay? Now the answer to this one is going to be plus or minus. Now the square root of 9 is 3, I know that. But the square root of negative 9 is going to be 3i. Okay? So again, basically, anytime you have a negative inside the square root, your answer is going to have an imaginary solution. Okay, let's do one more. So same thing on this one, right? So we have, let's see, subtract the 84 from both sides. So I get negative 84. And if you divide this by 7, you would get x squared is equal to, let's see, negative 12. Yes. All right. And then after that, to get rid of the square, I'm going to take the square root. Every single time you take the square root, you're going to have a positive and a negative answer. So the plus or minus comes from the fact that when you take a square root, you could either have a positive or a negative. Okay. So this is actually just going to be, I'm going to have to break this 12 down. All right. So 12 is 4 and 3, and 4 is 2 and 2. So I'm going to write this as 2i square root of 3. Okay. Now let's look at number 6. All right. I'm going to look at number 6. I'm going to give you the answer and see if you can get that. All right. So I'm going to write the answer here. The answer would be, let's see, where am I at? X is equal to I square root of 6 plus or minus. Okay. So just take a few seconds there. Take a few seconds to try to figure out if you can get that answer yourself. Okay, if you have more questions than that, let us know. Alright, we're going to go to the back of this. Alright, so we're still talking about complex numbers. And you can read that if you want to, but it really doesn't matter. So because I'm going to show you here in just a second. So first, excuse me. First, let's do some of these. All right, so these are easy. If you're adding two complex numbers, remember, a complex number just basically means you have a real and an imaginary number. Okay, you're gonna combine like terms, but when I say like terms, you're gonna add the real with the real. So negative 4 plus 6 is going to be equal to 2. And if you have 2i minus 3i, that's just going to be negative I. And that's all you do with those. So those are super easy. Right, on stuff like this, you just have to be a little bit careful. You have 5 minus I, and that negative will make this a negative 3, and that negative will make this a positive 2i. So 5 minus 3 is 2. I plus 2i. Negative I plus 2i is positive I. Okay, so this is the answer for that. So as you can tell, those are really, really, really simple. Okay, I'll do one more. I'm just going to show you the answer, see if you can get it. This one's easy. See if you can get this one. This will be negative 12 plus 9i. Okay. And let's see. Let me at least do this one. This one right here, notice that the 4 and that negative 4, they cancel out. So you have 8 times 8, so that's 16. I mean, if you want to write plus 0i, if you want to be that person, but that's just 16, right? Okay, so let's go ahead and move on to something a little bit more difficult, like number 7. So number 7, you actually have to FOIL this, all right? So we're going to FOIL just like you remember from Algebra 1. You're going to multiply that times that, so that's going to be equal to 6. And then you're going to multiply this times this. All right, and that's going to give me a negative 2i. And I'm going to multiply I times 3, and then I times negative I. So I times 3 is just positive 3i. And then I times negative I is negative I squared. Okay. Now we're going to add like terms before we move on. So when we add like terms, this would give us 6 plus I. Now this right here, remember that I squared, and I'm going to write this over here in case you don't remember. I is the square root of negative 1. So I square would mean that I would square both of these, if you will, and I would get I is equal to negative 1. So by definition, I square is negative 1. Okay, so this is going to be negative 1. Or in this case, negative of a negative 1. So you have to be real careful, right? So I squared by itself is negative 1, and that's negative. So therefore, that's going to be 6 plus I plus 1, which will make it 7 plus I. Okay? So again, be real careful with that. Don't mess that up. Alright, on this one I'm going to do the same thing, but I'm going to FOIL it a little bit faster. So we have 5 times 4, which is 20. 5 times negative I, which is negative 5I. Negative 2I times 4, which is negative 8I. And then that's going to be positive 2I squared right there. Okay. Alright. If we add some like terms, I have 20 minus 13I. I almost put 2 I's there. My apologies. And on this one, remember I have 2 I squared is a negative 1. So this is really 2 times negative 1. Okay. So I have 20 minus 13I minus 2, which is 18 minus 13I. Okay, if you want to try at number 9 on your own, this actually just gives you a negative 10I. So try number 9 on your own, see if you can get it. Now, we're going to go ahead and move on to like number 10. I think number 10 can be pretty difficult. What you're going to do, so you don't want to have an I term on the bottom. Okay, so what you're going to do is you're going to multiply top and bottom by 3 minus I, which is called a conjugate. Okay, it's called a complex conjugate. So the reason we're doing this, hopefully you'll see it here in a second, is because this right here is going to... Now I'm going to do it a little bit at a time. This actually, something like it turns that into calculus at some point, but this is not calculus. So this would be, let's see... 15 minus 5I over here, right? So I'm just multiplying that times that. Now on the bottom, remember, I have to FOIL this. If I multiply that times I have to FOIL it. So I have 9 minus 3I plus 3I minus I squared. Okay? So this would be 15 minus 5I. And on the bottom, notice that this cancels, and that's really what I want. I want the i's to be gone, and then I squared is negative. So on the bottom, I'm actually going to have a 10. Right, and if you don't see that, remember that's a negative, so I'm going to write it over here. This is a negative 1. That becomes a positive 1. If you add that to 9, that becomes 10. And this one, if you want to just reduce this, 15 over 10 would be 3 over 2. And this one would be... Let's see if I reduce this, that would be negative 1 over 2I. Alright, so basically trying to get rid of that one on the bottom, okay? Now, excuse me. Let me see if I want to do the next one here. Okay, so I'm going to go ahead and stop here. You can ask us about both of these questions in class if you like. So if you have any questions, let us know.